Okay, hi everyone. My name is Alexey, and today we're going to talk about CAN networks, ECUs, and some things in automotive. And you know, this is already a hot topic and a lot of people talking about it. And I'll try to make something interesting for you. Unfortunately, I'm not able to bring hardware here. That's reasons for that, because it's heavy. And it's actually located in Russia and belongs to my friends, not to me. But yeah, so anyway, I prepared a few demos and so on. Want to say that I have a lot of slides and not enough time, because 1 hour is not enough for me. That's why I'm going to skip few boring slides, like, you know, this who am I and so on. You could see everything on the slides. You don't need additional comments probably. And that's why you see where I'm working and what is my background and where I came from and a lot of things. So let's go to switch. It's another slide about this one I want to spend this few seconds, because we have a community in Russia. It's like a white hat, let's call it white hat hackers, and they are interested in automotive things. And actually, I need to say thank you to this community, because everything I done, they tested on real hardware, and I got a lot of feedbacks from them, a lot of information, and it's like we all work like a community here. That's why I put them on the slide, and you can see they have different interests. Some of them reverse engineers, some are going to build their own stand for car, like car but without wheels, and so on. And thanks to those guys, and let's go next. Is this slide going to be a disclaimer, because all this automotive talk starts with saying things like Charlie Miller, Chris Valasik did that. It's really like this, and this automotive industry has some issues, it's true, but it's not so bad as all people talking about, like they suck in security, they don't know what they're doing, and actually not. Yes, they like everywhere else, there are some security issues. Automotive not an exclusion here. So, but a lot of people I know who work for automotive, and actually my company here, it's also not a security company. I'm not providing any security services. I'm working in a company who busy in automotive development, and there are a lot of guys who trying to make things secure, but there are some reasons why it happens that or that, this. So anyway, it's just a disclaimer that I'm not going to sell anything or blame automotive industry. And this slide going to be like, you know, this intro, like, a lot of attack vectors, very big attack surface, and this is true, but I think most of you already know these things, and I don't going to spend again time on it. Yes, you could probably attack GPS and spoof GPS. You could try to inject virus frames into tire pressure system, wherever. Yeah, there's a lot of different things, and because my topic called like PenTesting vehicle, and this is not only CAN. CAN is very small part of all this, and actually this last part, when you already have car compromised. But how you get into the car, especially remotely, is a very big and interesting question. And I believe that a lot of new research will be published soon by a lot of guys, because a lot of people really working on it. And probably connected car is also an interesting thing, because it's attack surface extended now with all these backends and internet things. If you compromise internet service for car, you probably could compromise the car itself. Like, you know, this whole application unlock doors from the phone, they have synchronized from internet service and so on. And so it's, once again, attack surface is really big and not concentrated only on CAN security. But I'm here more concentrated on local interfaces, which is like OBD2 port and so on, but actually it's much more interfaces, like local access point from the car. USB port, actually. Some car has like Ethernet over USB, so if you connect simple Ethernet adapter over USB, you will get access to Ethernet network of the car, and a lot of things could be done here. But again, we are concentrated, this talk concentrated on CAN, and that's why I'm going to talk more about CAN here. And again, I need to mention the research done by Chris and Charlie 3 or 4 years ago about CAN networks, different topologies, and what you can do with ECU, how you could affect control on the car, and it was a really good research. Here I just want to mention that yes, CAN bus is one of the main buses, not only one buses, a lot of buses in the car. It's like kilometers of different wires inside the car. But CAN bus is responsible for controls and communicating between different devices like engine, I don't know, power steer component and logs, a lot of different things. And maybe main defensive mechanism what automotive vendors do is physical segmentation of network, because CAN bus is broadcast. Let's call it broadcast, because if one device sends a CAN frame signal, all other devices on this CAN will receive this signal, and already this device decide by itself is it supposed to be action for me or not. And that's why automotive vendors, they trying to do some segmentation, like critical paths are isolated from, like, say, OBD diagnostic or head unit entertainment buses. And I just want to mention it here. And yes, again, CAN frame is actually CAN bus. It's very simple technology, very simple protocol, like physical layer and transport layer is very simple. And maybe I just want to mention the most important fields in CAN frame is arbitration field. I call it ID because actually it also works as identification, like maybe source of message or destination, but actually there are no such terms as like source address or destination address like an IP. It's just only ID, and already it's different interpretation could be done on different layers. But arbitration field here is not designed not for ID, but for as an anti-collision system, because it's a differentiation pair and dominant bit here is 0. So if device puts 0, it's like signal in the bus. And if we don't want to have collisions, how it's done here. So let's say we have two devices at the same time they write message. They synchronize by clock, so they start writing at the same time. And the first field, as you can see, is arbitration field. So both of them write 0 on the bus, and at the same time they read in the message from the bus and they see 0. But let's say then second device sent 1 to the bus, but first device sent 0 to the bus. What does it mean? It means that the second device, who put 1 in the bus, has higher arbitration field value, ID, the value is higher. But when it's read from the bus, it sees 0 because the first device with lower arbitration field value sends 0, and it's dominant bit, so it sees 0. So that's how the second device understands that the first and another device in the network right now writing with higher priority because 0 in the network, and stop sending signals at this time. So probably it's important because it's from security point of view, it's also for us sign of denial of service situation. We could send a lot of messages with like arbitration field 0, 1, or like very low value, and it's mean that our other devices couldn't communicate anymore because they think some more important things happened in the bus. Probably I also try to miss these slides and do a very fast explanation, but actually it's what Charlie Miller and Chris Valasik did with last research. I wanted to show there that CAN bus is probably like last step of your research, of your tests. It's not the first, because if we are talking about remote attack vectors, and I already mentioned it before, it's more important how you get into the car. And for example, here you could compromise head unit with like million different ways, like Stack Overflow in a browser, or use of the free in the browser, and they have like QNX, and on the latest version of QNX has NX and SLR support. So I mean, there could be done a lot of research in this area, and this is really interesting topic. But then they need, like as I mentioned before, head unit has no access to privileged CAN, like it's critical to access to engine, for example, because it's in different isolated CAN segment. So they need second exploit to have a like local privilege escalation attack, and they need to compromise another component of the car, like gateway ECU is the best option here. Then if you compromise gateway ECU, we already have access to all buses that connected to this ECU. And then you could already send message and try to control the car. Yeah, also I want to talk about local vectors, because car is very interesting thing, and actually on this slide I'm going to talk about like you could put something inside your car. Like you could remove the front panel. You can get access to CAN bus, critical CAN bus, connect a small device acting as an MNDBDO, but with GSM modem, and then put this panel back. You will never find this device, but your car, like backdoor it, like physically backdoor it. And yeah, that's like possibilities what you could do, and it's mean, yeah, remote control. But okay, I'll skip this. So it's very simple ideas and not related to really to what I want to talk. But this one probably I'll focus more. It's also local vector, but already we are talking about real crime. But, you know, this whole remote attack vectors exploits, it's cool for researchers, but you never heard about real attack, like who hacked, exploited something and did some damage. But I believe you heard about thieves. That's real guys who are really interested into your CAN networks, unfortunately. And they have a different things what they could do with your car. For example, yeah, you have immobilizer keys and there's some cryptographic things there. And let's say thief, he don't have this device, but he's still able to steal your car because of different things. One of these, they use like different devices, let's call it exploits, just easier to have an analogy here. So they have different exploits, but unfortunately or happily, they don't exploit real bugs and issues. They use like common architecture design issues in CAN networks. I never heard about like use of the free in engine ECU to bypass key or something. No. But who knows, maybe in the future. Anyway, they really want to access to CAN bus to bypass this immobilizer, for example, checks and start the engine without keys. And when I'm talking about unauthorized CAN access, it's not only OBD2. The thieves, they know where is your real like, critical, important CAN buses. For example, in the first picture, they just make a small hole in the door. They found the bus, CAN bus, connect to this, they press a button, they send a signal unlock door. Now door is unlocked, they put it into the car. Now they try to do something with engine with same techniques. I will show it later, ideas about it. On the second picture, the same, they broke window, got into the car, remove lamp of the top, connect to the CAN bus because this lamp controlled over CAN, but also this CAN had access to something more interested for the for these thieves. And yeah, this real cases is how they work. And this is a black market. Like with exploits, you could find forum and run. They sell the Chinese devices for some price. They have this forum people who like judge. If you trust people, they have some like ratings for criminals. And this device looks like on these pictures. And yeah, this is how it is. And yeah, I mentioned here the protocol like ISO 14291, which is UDS. And this is, if you remember, I told you that CAN bus is just 8 bytes data and that's all. But modern communication it's not enough. 8 bytes are not enough. What if you want to send 17 bytes? So it's a next level, like next OCI model, we go up and you have UDS protocols. It's already, you could send any length message you like. And UDS, based on this ISO-TP protocol, it's diagnostic service protocol. It's like OBD, but in UDS you could do changes on the ECU, like you could reset keys, probably update firmware, change parameters of your ECU, and that's why those devices could be used for stealing as well. And okay, so time is good. I mentioned a lot of bad things, but actually CAN research not about bad things. It's also good guys here, like security researchers. And the problem here is that CAN information about CAN traffic in cars is not publicly available, so it's not documented. And researchers need to understand everything by themselves. That's why we have a lot of different CAN tools right now open sourced. And also there are a lot of guys who are doing some development like fleet management tools, small connected car devices you could find in Amazon, you could buy it. And those guys also need to do some research to understand how they could control what information they could get from the car and from the CAN network. And of course, anti-thief systems are also based on CAN, like custom anti-thief systems. So a lot of good guys doing also research in this area. Also, there are ugly things. I call it ugly because it's not crime like directly against someone, but people want to reset mileage counter of their car to sell it like as new. And for example, if car get into crash and airbags fired, they want to change these airbags and sell this car. But then they need to reset the VIN code of this airbag devices to put it in the car. So I mean, a lot of things happen here, and guys who are busy in automotive, which is not me, I'm a security guy from like other, I came from penetration tests, so for me it's also like new, I don't know what they know. And these guys, they don't want to share information. That's the thing. They keep everything for themselves. And yeah, and I came to the situation where there are a lot of CANToolz in the market, in the open source, and actually in the market as well. And they're cool, they're really good, they do what they designed for. But for me, I wanted something else, because if I want to do man in the middle, what I will do with this script? So I need somehow to automate these scripts to create a man in the middle. Another problem that most guys who making tools, they're making them for special hardware they do. Like they make a hardware, they want to sell it, and they tool. And for me, it's also not convenient, because I want to work with all hardware possible, so that exists on the market. So I want to have hardware independent software. I want to have API if I want to do some unit test, like not integrate my CANToolz with some other software, which could be used during development steps. Like I want to have validation test automatically, so something like that. And I want to have a lot of different modules that I could connect together like I want for this test. For another test, I want to connect it like another way. So it's like if somebody seeing the GNU radio interface, something like that. So I have different modules, I connect it together and have some solution for this situation. And I did it. So first release happened in February, so it's pretty fresh and buggy software. Yeah, and yeah, that's what I want to say. It's engine, support multiply interfaces, so you could do man in the middle, you could do whatever you want. You have a lot of ready-to-use models like fuzzers, UDS scanners, black box scanners, statistic analysis features, and a lot of different things. I have supported right now just 2 hardwares, just because I bought it for my money and add support for this, but it's very easy to extend for any other hardware. It's also support CAN socket in case you want to use it. Yeah, I think I speak this one because, yeah, you could have CAN over TCP, so if you want to have it redistributed for some reason, if you want it, I don't know in which situation it could be useful, but in my case, my friends in Moscow, and I live in Berlin, I want to work with SCA locally. And for me, it's one of the solutions how I can do this. But it could be done for any other reasons, just have. This is a design and architecture of my device, my software. Like it's unique, not unique, it's flexible, and you could use it in different situations. So main idea here that I have a lot of different modules. I connect it into pipe, and I have scenario, which is described in config file, and have step 1, 2, 3, 5, 6, then loop again, and 1, 2, 3. So it's like infinitive loop, and scenario repeat from time to time, again and again. And I have infinitive numbers of pipes, so I could do it like in parallel. So for this example of man in the middle with firewall. So then in this case, CANToolz acting as firewall. I connect it with 2 devices to one wire, and then cut the wire, connect one device to another device. So all traffic goes through CANToolz, and I could block any messages I want and see what happened. And this is config for this setup. So I have 2 modules for one interface, for another interface, and have 1 module for firewall to block. And then on one pipe, I read from first interface, then I write to second interface. On the second pipe, I read from second interface, one to first interface. So, and this is an example of man in the middle and firewall. And this is how it's described in actual config file for CANToolz. It could be GUI interface for this config, but I actually have no time to do this. So it's right now config only in text mode. I think developer API I will skip, but this is a slide about how you could create your own modules with any business logic you need. And it's pretty simple. You could do this. It's just general class, and you override methods. So that's all. And I want to say sorry about documentation, which, yeah, currently I'm almost the one and main developer of this thing, and don't have enough time to make a good documentation. But I have use cases, describe it, how to use it, and what you can do with type of tests, and so on. And for today's session, because I realized I don't have hardware to show you something like how real tests, real use cases that you could use, I have idea to create a virtual car. I was inspired by the guy called DN5 because he created a virtual car for himself, written on C. But C is not a good thing for me. I think it was C. But the thing here that I decided to create my own emulator, but based on CANToolz engine. So each ECU is module for CANToolz, and each pipe is in different CAN bus. So it's isolation emulated, so physical isolation emulated, ECU level emulation here, and CAN gateway is also just a module for CANToolz, and all this monster act as one car, like as a real car, and it has UJS services, RPM, engine, doors, lights, and so on. Yep, that's how it looks like. So you could run it, you have some controls, not few of course, it's just simple small like stand, demo stand, but it's enough to understand like how cars works. And let's finally start to talk about actual tests and what you can do and why you need to do. Actually, here from this step, I don't want to concentrate more on the like CANToolz can do that or that. It will be not interesting to talk. I want to talk about like different methods you could do in CAN network and different techniques the tester or other guy could do on the CAN network. For example, here, the simplest thing you could do is start to work with OBD2 port because it's accessible. You don't need to destroy your car. It's very easy. And yeah, by standard, pin 6 and 14 always responsible for diagnostic CAN bus. But I want to say for testers, you could see here, and I have a lot of make, model specific thing. And actually, some of vendors, they put other CAN buses, let's say through pin 1 and 9 or 3 and 11, they could be additional CAN buses. That's like not by standard, but vendors decide to use these pins for access to additional CAN buses. And for researcher, it's not a bad idea to check this model-specific pins to understand what's actually there. Probably it could be another CAN bus. That's first thing you start. And then if you finally already have access and you could sniff some traffic from this OBD and see what's inside, probably not much because it's just diagnostic. You can't probably send like signals to engine and so on. But we already talked about UJS before that it's used by attackers, by thieves, and for do some changes in your ECUs to make your engine start. And this thing available from OBD. It's important because UJS is like diagnostic service, unified diagnostic service, and it's designed that you, for example, came to service centers, they connect special vendor-approved software, do some diagnostics, you do some changes on your ECUs, like to make mirrors after unlock, or like any customization that could be done only on ECU level, you could do only from service center. But they do it from, on common cars, at least on modern cars, from UJS protocol, which available from OBD port. And if you have this software somehow, download it, and you have friends in service center, you could just sniff traffic to understand how it works, to, for example, understand how authentication works, and so on. Or you could do just reverse engineering of those tools and understand more and more. But one of the examples, it's, not this button, this button. It's UJS scan. It's, by default, let's say I don't have these tools, I don't have this vendor's tools, but I want to find these UJS services, which I don't know. So it's the same analogy with port scanning, with TCP port scanning. So here we want to send a CAN frame to the OBD port with some ID with UJS request and see if response on this request came. If so, then UJS service exists on this ID. If not, then add next ID and enumerate all IDs like port scan. And it's pretty simple, and probably it's implemented in other tools, but I also did it. Here in CANToolz, it works with two modules, GAN, ping, and mode start. And I could actually show you some demo. It will be not so boring. So first of all, I start my car. I start second CANToolz, and I try to find the mouse. Yeah. So let's check. So this is car, a car emulator has CANToolz. I start it, then I go to car interface, make it bigger a little bit. Yeah, this is our car. We could start engine. We could make RPM more, like here, we could unlock, lock, turn lights, so on. And we want to find UDS services, so it's like Carmulator, so I start the second CANToolz, like different tool, which is connected to OBD port. Here, it's here. Yeah, I want to make it some bigger. Yeah, I'm very bad in HTML and CSS. That's what you need to know. But I have console interface, and this is just front end. I have web API, so you could, if you want, you could write any web interface you like. And let's see what we have in OBD2. Here, it's OBD, it's mod start, and we could see message on OBD2. So always you generate messages here, and you could see this. And this GAN ping, we have configured to make scan on this range of IDs for services number 39, which is authentication request. So we try to request authentication. Then we just press button start here, wait when scan will be finished. And then if some UDS response happened, the mod start should able to catch this as a UDS session opened. So as we should press here, analyze traffic for, let's say, UDS. And it's very small. I tried to make it bigger, but not so easy without mouse. But okay, it's here. Service with number 701 in hex responds on seed request with this data, which is probably seed for authentication. And that's how we found via black box methods, we found the active available UDS service from OBD2 port. Okay, that's just an example how easy it could be done. And back to probably presentation. No, presentation. And time already. Well. Okay, let's go. And this is example from real car, from the guys from CANToolz. They just connected to their car and do scan for service number 10, which is entered diagnostic session, and a lot of device replied. Here, I just want to mention that real life is always different from what you could read from the books, like car hacking books, because in this case, UDS offset was different, and how you could understand that this is response. Because you send, let's say, we sent request with ID 1, and then we got response with ID 9. So difference between ID is 9. And it's by default like described in UDS protocol that each response should be +8 to request, because there are no source or destination address. So it's very difficult to understand who is sender and who is receiver here. That's why in this protocol they have this trick, like a response should be +8 from request. But in this car, a response, this offset was different. It's not standard, and you could very easily understand it from the traffic. Yeah, but yeah, time is going, and we need to switch to another examples. Another example, we have the two diagnostic tools for this car. We also connected and could sniff, and you could see a lot of interesting data of like which ECUs you have, names for this ECU, and CANToolz could detect ASCII symbols in this traffic, so you could understand what this ECU is about. But more interesting is authentication, and on this example, Anton, my friend, he tried to run some change action. So he has ECU like mirrors. He wants to disable this after close, like on turn off. So it should be changed as parameter in ECU. So he runs this diagnostic tools on this section and sniff it with CANToolz, and this is a result of the sniffing. And as you can see, the first part is authentication here. So device, diagnostic tools send a request for authentication and they go from the car response. And then they send second request with another wire. It's actually key and seed, so they did some magic and get authentication key and send it back to the device. After that, they already could use another UGS command called write by identifier, and they write some data to this parameter. So they have ID, like table IDs, which like parameter ID and value. So they have ID, which is probably 5, 20, or just 20, yeah, 20, and the value. And then send it to the device, and the response like 20, it's written. Then they write something else, and then they like confirmation, they read the same parameter to check if what they read, what they tried to write is actually written to the ECU. That's all session snippet, and in CANToolz, like you easily could restore the session step by step. And if you ask about authentication, yes, it's seed from ECU, and this is auth code from the tester device. But then you just, after we run this second and third time, you even don't need to do reverse engineering. It's very simple. Unfortunately, you couldn't see the last part of the slide, but it's just a function of addition. So they have seed, they have pin code, they add pin code to seed, and this is actually our key, so even not XOR. And at least we know how to do authentication. If we want to create some custom UGS tools, we totally restore the whole logic from this. But because I mentioned that CAN is, UGS is important for thieves, I want to show the demo I have here. So let's back to the car. Let's stop it. And let's remove immobilizer keys from this car. Okay, I first need to remove keys, and you will not see how I do this because actually the file is closed. Wait a second, I need to open. I don't see. It's here. That's not easy. Examples. Car. I'll do it faster. Oh no, everything. So I have controller here for engine and have key. Let's remove it and save and start car again. Which is not easy because two screens. Okay. And then go to the car. And if we press start, nothing happened. Without key, we are not authorized to do that. Probably, yep. Wait a second. Yeah, but we could do other things, but we can start engine, everything right. And then I go to the demo. Here, and let's say we drill a hole in the door, connect to the bus, and we want to send a signal like unlock door. It will be more. So I know the command. How to do this? And if I send it, nothing happened. Probably I will. Let me check. I don't see. Yeah, probably I did it in wrong. Yeah, it should be here. Sorry. I sent it to OBD2. And because OBD2 is not allowed to have access to cabin, nothing happened. So I sent it from. Yeah. So now we're inside the car. Now we could connect to OBD, for example, and this is the thing. UDS key for access to the device is shared. I mean, if you know it's for one car, you know it for all cars. Keys for immobilizer, it's unique for each person. That's one of the things that could be happen. So attacker, he don't know your immobilizer key, but he knows the UDS key. So what he could try to do, and this example, he uses key here. Let me first copy it because I don't remember. From the engine, right? So I need to copy UDS. Ah, come on. Wrong button. Okay, here, secret. And then we try to no, not here, here. Actually, it's not even here. Yeah, I can see from this. Yeah, looks like I'm right. And we do authentication. And now we could write a parameter because we already authenticated in UDS, and identifier will be 50, 50, 50, 5, 5, 5, 5, 5, 5. And we set a new key, which is 17 hex zeros. Let's make it 0. So 1, 2. So probably now we reset keys from SU engine. And now, because we know this key, we could try to start this engine. And first we need to get the VIN number as well, because, yeah, I get it from here. I don't see really. I think I copy everything. So we set up a VIN code here. And now our new key, which is 17 zeros. And now we could try to start a car. There's this, we put that, and yeah, and now we have RPM and everything. So this is like example on the simulator how it could be in real life. I can't say this is example one-to-one because I'm not a thief, but that's how it's supposed to be. But actually, there's a lot of different situations. Sometimes thieves can came with their own ECU to start engine. They connect it to your car and they use this ECU to control engine, not the original one. So there are a lot of different tricks and techniques that thieves are using. Okay, 47 minutes. I need to be up. Yeah, but first I need to switch to presentation. Yeah, this scenario was shown. And let's go to the next thing. Actually, it's not a commercial, but it's very popular book. That's why I decided I could put, here everybody heard about it. And I also bought it and read it, and it's a good book. And do you remember at the beginning I sent the comment how to unlock the door? Like I put something. So this is the thing. Actually, originally I didn't know how. I didn't know this comment. I need to do some research to understand which comment it should be. And for example, in this book, I wrote like a good example. You could dump a traffic with when you did an action where this unlock comment happened. Then you replay half of this traffic and see door unlocked or not. If not, then replay another half, and for sure it will be unlocked. Then you take this half, and again, it's like binary search. It's a cool technique and it works, and in this book you could see like how you could do this from scripts like replay ID from this or this. And why it's so boring? I mean, CAN network is really easy. You could do a lot of automation in this, and unfortunately I found no tools that could do this. So that's why one of the reasons why I have started doing CANToolz. But first, you need to find the right CAN bus. It's another task for the tester because like for black box, you get a lot of wires. Like a lot of wires, really. It's kilometers of wires, and you need to find CAN buses. And what our car parent team use in Russia for their car, they use simple multimeter, and they check the resistance, because if a CAN network is terminated from both sides, resistance should be 60 ohm. If it's disconnected, 120. So you could find the CAN bus based on these simple things. Of course, if you have more advanced devices, for, I don't know how to say in English, in Russian we call it oscillograph, but yeah, you could do it actually with multimeter. It's very simple, and how they did it. And this is last picture is how they inject into the CAN bus, because I really don't recommend to do any cut in the car. It's not a good idea. So we just took simple needles and connect, like really connect. And first method I want to present here, which is very simple. It's just difference of two sets. It's much faster and simpler than replaying half by half. So we have first traffic dump, we call it set 1 with noise. We collected traffic, for example, for 2 minutes and did nothing for the car. So just normal traffic if nothing happened on the car. Then we collect the second dump of the traffic, which is where is event happened, action, like unlock door, and there's a small amount of traffic, but actually for a few seconds it could be like 1,000 different CAN frames, because there's a lot of traffic in the bus. And then you do a simple diff and find the difference between these two traffics, and probably this difference will be what you're looking for. This is an example again from real car, from the same, my friends from Moscow, from Mikhail. And you see on the first, on the first picture, it's like diff, how it looks like. It's not 1,000 packets. It's already just 20 different frames, and it's much easier to find the frame you're looking for in this set than in 1,000 or replace. But even more, it's too much. For me, I decide and I add additional filter, like how many different changes happen. Because let's say in this frame, it could be RPM as well, because RPM changes all the time. And in the bus, it's a lot of different values. But it's a lot of different. We don't look at it, because lock-unlock, it's binary structure, so it's one value and another. So we could set, for example, in CANToolz, filter on only 2 different values and see already only 4 different messages. Already here, by statistic, you could see this is 5, 5, 5, and 1. So this is 1, probably what we're looking for. This is 5, it's status messages. Before it was 80, for example, and now it became 0. It's because before it's statuses. It's always sent. Door closed, closed, front door closed, left door closed, and then you did this action, and they changed. Of course, they changed. Like now it's opened. That's why it's also in the diff. But if you put filter with value 1, you find exactly this responsible, like main event we are looking for, and it's much faster than doing replayment. Yeah, I think I will not show. I mean, it's very simple. I don't want to show this on emulator just because of time, but yeah. And then we took another car, and it's more interesting case. The diff already really big. And if you set filter on 2, only 2 values, we're looking changes from one value to another. It's also few, and there are no unique, like by count. You can say what exact message here. And if you put, of course, 1, there are no unique messages. So the answer is somewhere here, and it's not difficult to find it by replaying one by one, but still it's not as clear as in previous example. I just want to show that different car has different logic. And that's how I came into second method. I just specially created for Black Hat, just finished yesterday. And it's based on abnormalities. So we're looking for abnormalities in the traffic. First, I thought, oh, machine learning, cool, but no. Machine learning, not good thing everywhere. Here, you could do machine learning, but education period will be like super long, even simple replay will be faster. So I tried to use another method, like this simple statistical analysis and abnormalities detection. So I checked for 2 things. First, beat that has been changed. Is diff method change values, like different values. For example, 1, 2, 3, it's all 3 different values. But if you choose this method, it's same beats changes all the time. So for us, it's not interesting. We're not interested to make difference between 1, 2, 3, because if same beats changes all the time, probably it's noise. So I have a history of all changes and which beats has been changed. And I remember this beats for each ID. And also I remember the time between same frames. So if each second, okay, I remember this minimum time. And on stage second, when I have the second set of traffic where action event happened, I do the same. I understand the minimum time and for each ID and beats that have been changes and compare. If new beats found, it's abnormality for me. That's how, for example, RPM excluded by default, because it's almost same, not always, but always same beats changes all the time. And a lot of noise removed very fast. And next, stage 3, I do correlation between different events. So if this changed first, and then after this, another ID change, probably these two events are one big event. So I collect all these things, and as output for same traffic from previous example, I got session extraction. It's like, if you do door unlock, it's only these frames, let's say, interesting for you. And they sorted by time here and by logic. Like this first change happened in the traffic. Then this is second change happened for another ID. Probably it's correlated because this happened just after this. Then other changes happened. Then impulse rate, the message start sending more often, and so on. And it's look cool because by logic, of course, unlock command somewhere in the top and statuses on the bottom. It's just by logic. But it's still not all what we can do. And next step will be automatic detection, even without like human participating. So what we can do now, when we have the session extracted by this statistical method, we could replay message one by one from this session and then check if these changes happened. So if we replay this message and this change has not happened, then this message did not cause these changes, so it's not what we're looking for. Then we replay second frame from this list, and we see, yeah, that's now changes. This value changed from this to this, and all this fix happened. So it's mean this is what we're looking for. And actually, even if by values, you could easily see that it was changed. So this is what was 8888, became 2222, and just after this, all this EC, like EC, EA, A2, EE, and also it's important because same mechanism have close ID. So it's like door 1, door 2, door 3, door 4, and they have while they have a close ID values. This change it while second from 5th to 8 bits. They change it from 1 to 2. So it's like it looks like this is statuses of the doors, and this is command. And then it's back. So it looks like it's like button. It was pressed during this time and it's released. And it could be done totally automatic. And probably this I want to show on the stand. On the emulator, I mean. Let's see. So I restart different example. So what we have in the car, let me check this car status. Let's close doors. Okay, let it be unlocked, whatever, it doesn't matter. Start it. So in what start, let's check if we see it. Yeah, we see some traffic here. Let me just make it bigger. And now we can go and let's and make a train session on the buffer set 0. So here in CANToolz, it's a lot of different buffers you could operate with. So by default, it starts, if you put current status, that all actions and buffer, default buffer with index 0. And it's how many frames here snippet. So because nothing happened with the car, it's noise. It's what we could use for learn, for training. So we do here training, press it. Then we could see here, yes, we found how many? 6 unique ID, and we done training. So now we could switch to another buffer here, and then we could do an action on the car. Let's say lock, and go back. So we don't need this buffer anymore. So let's see. So in buffer 0 we have already some traffic, and we already made a train. On buffer 1 we have 200 something I don't see from here frames, and we could try to extract a session. So it's an index 1. And it's the result what we got here. It's this example very simple. I mean, you don't even to replay because it's first message, then those changes happened, and this is another correlation information. So probably you say this comment is lock, and this is door status 1 door and 2. I have 2 doors. It's sports car. But I also want to show back to the car, make it unlock again, and back to this one. And let's try to run after detect feature. Hope it works. Where is the button? Yeah, you see door closed. And as a result here, let me check, I don't see from here. Yeah, this is our answer. We have the after select, so you really don't need to think too much. I mean, some things could be really automated in CAN bus, and that's what I tried to do. Yeah, I see. I have only 5 minutes and a lot of things to talk about. That's okay. And I want to say I have a lot of features in development, for example, automatic field extraction, because it's also interesting task, because you see, yes, it looks like one message, but there could be different fields in one message. And we could, for example, this feature done by my friend, Sergey, he doing XOR one by one each for all sequence to see which bit changes more often than other. For example, if 2 bits changes in 2 different ages of field, it probably it's 2 different fields. That's how this is, again, it's from real traffic. We could apply this mechanism, this idea to select probably this is RPM and this is speed, because car was in statical position, not moved during research. And we could separate speed from RPM from one message. And actually, yeah. And also I have metadata support in CANToolz, so if you think you know what you have found, you could create metadata config file for your project, and then you could document, and then data extraction will be already automated. From these messages, you could detect RPM value, and it's probably speed. And comment which this ID is responsible for this. And if you give this information to another researcher, for him it will be easier to understand what you have done, and so on. Okay, faster. That's already showed you. It's how I also custom-made algorithm to detect loops, because very often Win code send, for example, in loops like repeatable Win code, it's never changed, and they don't use this OTP for this type of information. They use custom like counters. You could see it's like 0, 1, 2, 3, 0, 1, 2, 3, and they repeat it again and again. So I have implemented something like we could reassemble this chain and get the ASCII string. So it also could be useful. And a lot of other things, not only research. I want to talk also about validation tests and how you could do it with CANToolz. For example, it's very not bad idea to validate what's that. This is CAN gateway. And of course you have, for example, one bus and another bus. And you want to be sure that the configuration of this device is meet your requirements. And the problem in automotive that requirements done by, let's say, automaker. But this device done by some company, not by, so it's different company who did this device. Yes, yes, by request of vendor, it's like a relationship between them. But technically it's different team, different person. And of course, like vendors, they need somehow to validate what they bought. So probably it's one of the ways how they could do this. They could, and I tried to implement this in CANToolz. For example, I sent all tests, like unit tests from one interface, and on another interface of CANToolz, I connect to another part of the device and check which message passed, which not. And it could be done like automatically, but okay, time is time. And I want to say also about fuzzing. Actually, you could do fuzzing in a simple thing. I mean, you understand what is fuzzing, how it works, but problem in CAN networks, it's very difficult to understand if this frame you did for fuzzing cause some issues, because you don't have debugger attached to ECU device. You probably could do this. It's okay, it's one of the solutions, but in general, if you send a message to the CAN bus, you don't know what happened, or if something happened or not. And you don't know if your fuzzing found something. And that's why you could do a little different things, and I think here link to some paper of some academic guys who working on this area. But I also found that the same algorithm I implemented for automatic door unlock detection, you could use for fuzzing. Because I have no time, I can't show it right now on the emulator, but idea is the same. You do fuzzing, you learn your algorithms, then you do fuzzing, and then you see correlation happen between messages in fuzzing and other messages in the CAN frame. For example, you have like the device send message each second. You did fuzzing and it stopped sending message. And you could definitely say after which message it happened. So here it's you could do this. And it's a lot of okay. Next thing is alternative systems, and unfortunately I have no time, but the thing here that you could use CANToolz for prototyping, because yes, it's very difficult to create a device and connect to car, check something, then you need to back device, do reflash. You could create a prototype in CANToolz on Python, like with all business logic, very simply connected to real car, check the logic. On the fly, you could change the code and change it on the real boards, stands or real cars. So it could be helpful for developer. And here I have example of anti-theft system. So first idea, because I have no time, I can't show it right now, but I could at least say a few words. First, we could connect our device before, like we could cut the engine, cut the CAN before the engine ECU, and put our device, and this device do additional filtration. So for example, it could be anything. In my setup, and actually I took this idea from real custom anti-theft system in Russia, you like need to put a secret sequence actions inside car, like you know, like fatality in Mortal Kombat, like up, up, down, and then you could start your car. Without these actions, you can't do this. So I did a prototype of this for my emulator, and it works. But this is a bad idea, because if you make a mistake here, you lost control of your ECU engine. So another idea, connected in parallel. Then if your device crashed, nothing happened. But this is the same idea. It's checked for left, right, left, right, secret sequence. But if it detects the engine started, it's immediately send command stop. So it's like for intruder, it looks like he could start, and then in a second it stopped. So I also took this idea from real prototypes, what I saw in Russia is custom anti-theft systems. Ideas. It's a very popular idea, and on Hack in the Box there was even some poke, and the guy promised to put it on open source. He didn't do this, I can't say anything, but he tried to make a machine learning system, and for his own machine, he made an education process for first step, and then he checked that RPM and speed should be also correlated. If it's not correlated, probably some attack happens. Okay, and yeah, this is contributors who helped me a lot. And for example, my wife did all this graphical design. Thank her. This Sergey did some algorithms for bit XOR detection, field detection algorithms, and so on. And so I think I have time for questions at least, maybe 1-2 questions. So, sorry, I have a lot of information and not enough time. Yeah, my fault. But if you have questions, please welcome.
Really quick, do you have a suggestion?
Do you have a suggestion of where you could get like a car parts from to actually test? Do you have to go to a junkyard and actually buy a used car, or can you find individual pieces on eBay or something, for example, to
Yeah,
test?
that's probably. If you remember the second slide, there was a picture of this. So you could buy pieces on eBay, but you have problem because there are no information on how you could connect those devices together, how to make a power supply. And for example, some ECU devices, before they start, they looking for other ECU devices, and you couldn't start. So you need to first to do small research, and then you could connect it. And actually, a friend of mine, Sergey, he worked on this. So he put all these details as separate details, and he started connected, and he has kilometers of wires in his laboratory. And yeah, it's possible, and it's much more safer for you if you want going to do research, because it's really not the best idea to do research on your own car. But eBay is one of the sources, and also in Russia, for example, we have a lot of crashed cars, and you could details from these crashed cars somewhere also. So it's not a big problem. Biggest problem, you don't know how to connect it. This is the biggest problem.
Thank you, ladies and gentlemen. We're out of time. If we give a hand of applause.
Thank you.